So continuing our journey on finding the solution of a quadratic polynomial, today in this lesson we are going to learn about how do you solve quadratic polynomials using the complete square method. Okay. Now in this tutorial we will also be using some standard identities. So one of them is a plus b whole square is equal to a square plus b square plus 2ab. Right, we have learned about this in the past, and the other standard identity is a minus b whole square is equal to a square plus b square minus 2ab. Okay. Now, the given task is I have this polynomial. The question is this: the 2x square plus 24x plus 64 equal 0. And we need to find the two solutions or two zeros of this quadratic polynomial. Okay. Now, there are few steps in this solution process, so let's pay attention to those. The very first step is, let's rewrite our polynomial in a way that we are separating our terms so that all the terms containing the variable are on the one side, the left hand side, and all the terms containing the constant values only are on the right hand side. This is our step number one. Step number two, it is that we want to divide this entire equation by a value such that the coefficient of x square is always converted to 1. But in this case, I see that the coefficient of x square is 2. That means I have to divide this entire expression by 2, right? So when you do that, what happens? When you do that, you have to divide this by 2, you have to divide this by 2, and you have to divide the right hand side with 2 as well. So that leads to step number 2, that your new expression will be x square plus 12x is equal to negative 32, right? And now step number 3, what you do is you rewrite this expression as it is, and then take whatever is the coefficient of x, you take the half of that, make the square of that, and add that on the left hand side. And likewise, I'll do the same exercise on the right hand side. That means I'll take 12, which is the coefficient of x, divide that with 2 and square that, right? So if you were to simplify your step number 3, I could rewrite something like this, that this is x square plus 12x plus 6 square is equal to negative 32 plus 6 square. So in this case, if you look carefully and if you compare it, the x square is equivalent to the term a square, right? The 6 square is equivalent to the term b square, right? And the term 12x can simply be written as 2 times 6 times x, which is nothing but similar to the term 2ab, right? So that means I can simply rewrite my entire expression, and the left hand side can simply be converted to x plus 6 whole square. I'm just making use of this standard identity that I have written here, right? And this is equal to, when you solve this mathematics, it is equal to 4. And this can be said equal to 2 square. Now what exactly you have accomplished so far is that, if I label this as my step number 4, that you have converted this original expression, which was in this form, into something that is a complete square, right? And that is why it is called a complete square method. Now to find the zeros of this, what you need to do is you can simply take the square root of this whole thing, right? Meaning you'll take the square root of 4 or you will take the square root of 2 square. And then you can say that from this point onwards, I can reach this conclusion that x plus 6, which is the square root of x plus 6 whole square, is equal to 2, right? I'm simply taking the square root of 2 square, and it can be said it is equal to 2. Or x plus 6 can also be said it is equal to negative 2. Because whenever you take the square root of any number, you can have that either as a plus value or a negative value. This is a very standard thing we have learned in our elementary days, right? And this will give me exactly two solutions, that x is either it is equal to 2 minus 6, that will be negative 4, or you can say that x is equal to negative 8. So these are your two zeros or two solutions that you can apply to this original polynomial that you have. So you see that using this complete square method, the equation that was originally with you, you have converted that into a very simple form and then you were able to find your two solutions, right? Okay, now let's take a look at a little bit more complicated example compared to this example that we have. Okay, let's go take a look at that. All right, so in this one, my quadratic equation given to me is that 7x squared minus 8x plus 3 equal 0. Okay. Now, since it is a rule-based method, let me follow my steps very methodically. So, very first step is I will separate my terms containing the variables and the constants. Second step, I will simply divide this whole expression with 7 so that the coefficient of x squared gets reduced down to 1. So, when you do that, you get x squared minus 8 over 7x is equal to negative 3 over 7. Okay. Step number 3. Now first let me rewrite this one, whatever I have obtained in step 2, and then add 1/2 of the coefficient of x, which will be 8 over 7 times 1/2, and add exactly the same value on the right hand side. That means I will add 8 over 7 times 1/2 the square of that, right? So at this moment, let me rewrite my step number 3 and make it a little bit simpler. It is x squared minus 8x divided by 7 plus 4 by 7 square, right? And the right hand side is negative 3 by 7 plus 4 by 7 whole square. So at this stage, what you do is you take your step number 3 and try to compare this expression with those standard identities. And one standard identity I can write here is that a minus b whole square is equal to a square plus b square minus 2ab, right? So you simply see that x square can be equated to a square. And you have 4 by 7 square, it can be compared to b square. And then you have 8 over 7x, it can be compared to negative 2ab. Why? Because I can simply write this 8 over 7x as 2 times 4 by 7 times x, which is nothing but 2 times b times a, which is exactly what we have here, right? Or in other words, I could convert the entire left hand side of this expression to simply this form, which is x minus 4 by 7 whole square. And the right hand side, when you solve this, you will find that this entire value is equal to negative 5 over 49. So this is equal to negative 5 over 49. By the way, this is my step number 4, right? So now it is time to take the square root on both sides of this expression, right? So we do this. And here is complication that you have a negative value inside of a square root, right? And that's a problem because you have never dealt with that value before. So what you do is you break down this into two parts. You take negative 1 and take the square root of that and multiply that with square root of 5 over 49, right? So negative 1, it gives you a unique value. It's called iota. It's an imaginary number, right? And the square root of 5 over 49, it gives you square root of 5. When you simplify it, divide by 7. But as we have learned before, that whenever you take the square root of a number, you can have two values. You can have a plus value or a negative value, right? So this is what we get after taking the square root of this constant that is on the right hand side. So that means that x minus 4 by 7 whole square, when you take the square root of that, you get x minus 4 by 7 is equal to, if you take only the positive value, one possible option is iota times square root of 5 divided by 7, or if you were to take the negative value of this number, it will be equal to negative I or negative iota times square root of 5 divided by 7. That means what? That means you have two possible solutions. You have either x is equal to 4 by 7 plus iota times square root of 5 divided by 7, or you could have x equal to 4 over 7 minus iota times square root of 5 divided by 7. These are your two possible solutions of this original polynomial that we had as in step number 1. Alright, so with that, we take a pause here, and in our next tutorial, in next lesson, we'll learn a different method of solving quadratic polynomials.